The first thing you're going to do is your warm-up where you find and fix the errors. Press pause to give yourself a couple of minutes to work through that. And then you're going to need to open your Canvas ePortfolio so that you can add to your vocab. First, I want you to think about what are graphics. They are anything visuals we see on the screen when our program runs. Pacman is a fairly simple and the best ever game created, but it is considered to be one of the most important video games of all time. Let's break down everything we see here to think about all of the graphics this game uses. What graphics do you see in this game that move or change somehow? Well, Pac-Man moves around, ghosts move around, small dots disappear when eaten, large dots are flashing, 1-up is flashing, scores at the top scores at the top increase, Ready Player One shows briefly at the start. What graphics do you see in this game that don't move or change at all? Well, the background, the maze itself, the walls of the maze, the extra lives, and the cherry bottom, the words high score. What interactions do you see Pac-Man having? What can the user do with Pac-Man, and how does Pac-Man interact with other things on the screen? Well, Pac-Man can move up, left, right, and down. Pac-Man eats dots when he runs into them, and Pac-Man cannot move through the maze walls. So the first thing that you have here is a library used to create programs with graphics. So that would be import TS app. So Python has a number of graphics libraries. TS app is the one we will use in this class. The TS app library is available in any activity you work on and is documented in Code Assist rather than in the assignments panel. So what I want you to do is I want you to try to change the on-screen position of the chicken and change the size of the chicken and change the background image. And in order to do so, you will need to open the project panel and find your Part 2 dramatic chicken. So when we open this up, look and see what the program does. Go ahead and run it. Oops, wrong one. Can I get to there from here? I don't know if I can. Go ahead and run it on your own. Okay, so when you look at it, you've got this chicken. Okay? All you have here are some graphics. You can move your mouse around. Nothing yet is happening. And, okay, there we go. So what it does is it draws a chicken in the foreground and a field in the background. What I want you to do is experiment changing the code to see what happens. And I will go back to this. These are the 3 things that you need to look into changing. Go ahead and take a few minutes to do that. Okay, the next vocab is window. And window is simply a container for displaying graphics. So if you look at the code below, you'll see window equals TSApp, which is your library, dot graphics window. So many of our text-based programs just run in the Python console, but any program we've seen with images or animations has used a TSApp window. To create a window, you create a new instance of the graphics window class from the TSApp library. We need to assign that window instance to a variable so we have control over what is displayed within that window, and we'll usually call that variable window, but you can name it anything you find that is useful. A sprite is an on-screen graphic based on an image. So you could have dog equals tsapp.sprite. Then you see an actual image name or file name of an image, dog.jpg, okay? And then you see comma 0, 0. And below that you have window.addObject and shows that you're adding dog, which is your variable or instance. So Sprite is another class defined in the TSApp library. And we'll create a new Sprite instance for each visual element on our screen. After creating a sprite, we also need to add it into our window, otherwise the sprite won't show up. In Pacman, there are 4 ghosts that each move around on their own. To achieve that, we would have 4 different sprite instances in our window. Can you think of any other sprites that Pacman might use? So when we're creating a Sprite instance, we need an image file in our project for the first argument. These image files can be either JPEG or PNG, which are 2 file formats that computers use to store image data. JPEG images tend to have a smaller file size but cannot have transparent backgrounds, while PNG images tend to have a larger file size but can have transparent backgrounds. They don't have to have them, but they can. We can't upload our own images, but there's a large set of images available for us to use. Let's take 2 minutes to explore our options. Follow the instructions on the slide with 2 minutes to explore. So, Sprites use image files. Open the project panel. Under Images, click Add Image. Explore the categories under Sprites and the backgrounds. So, Sprites have a ton of features that we'll start exploring today. Open up the Code Assist entry for Sprite and take 1 minute to read through the available attributes. Read the Sprite entry in Code Assist for 1 minute. What attributes did you see that deal with position? X, Y, those are your XY coordinates, center, X, center Y, and center. How can we flip a sprite sideways or upside down? Flip X and flip Y. What other attributes did you see that you're excited about using? So you also have coordinates, which is your X, and that's horizontal, and vertical is your Y position. And they are usually written and read X, then Y. So when talking about the position of something within a window, we'll use X and Y coordinates similar to how you do in math class. The X attribute is used to control horizontal, left and right position, and the Y attribute is used to control vertical, up and down position. The second argument, when we create a new sprite instance, sets the starting X position, and the third argument sets the starting Y position. We can also set the position of a sprite by changing the X and Y attributes. Position is measured in a unit called pixels, which are the tiny individual dots that make up your screen. One important difference in coordinates used with code compared with math class is direction. Both here and in math class, X gets smaller when you move to the left and gets bigger when you move to the right. So there's no change there. However, when we code Y, it gets bigger when you move down and smaller when you move up, which is the opposite of how things work in math class. Why is this different? Programmers picked the top left corner to be 0, 0 because computers were originally used to display text in English. We read text by starting in the top left corner and moving right, then moving down at the end of each row. Computers followed this pattern. Because of this reversal of the Y direction, the origin point 0, 0 is in the upper left corner, not the lower left corner like in math. You can remember this by thinking about the coordinates like you would read a page in English. Start in the upper left corner, then read to the right and downwards. By default, our windows are 1016 pixels wide and 573 pixels tall. So at the bottom right corner, X is 1018 and Y is 573. Another vocab to add is your main loop. It keeps a window open and updated, and you probably want to copy your code there as well. We could put everything we've learned today together, creating a window and adding some sprites as specific positions, but our program would end just as it began. The main loop of our program is what we call the while loop, that has all of our code that updates our sprites, gets input from the user, and generally performs any other repeated actions necessary for our game or app to work. In Pacman, this would include the user moving Pacman around the ghost, deciding where to move, checking if Pacman has eaten any dots, flashing the power up dots, and everything else that changes over time. The condition for our main loop is always the same. We check if the is running attribute on our window is true. This attribute is automatically set to false if the user closes our window, ending our main loop after its current iteration. We can choose to set is running to false in other cases as well in Pacman. Once Pacman runs out of lives, the game is over and we can close the window automatically if we want to. For now, our main loop will only have one line inside, which is required. The finish frame method is what updates all of our sprites within our window and generally keeps our game running smoothly. The finish frames method is also what checks for the window being closed. So without calling this method at the end of the main loop, you will hit an infinite loop without any way to close the window and end the program. Let's put it all together to create another graphic scene, but this time by writing the code ourselves. So let's go ahead and open part 3, simple scene, and end this video and move on to the next one.